Good evening, everyone. Once again, I welcome you all on the sixth day of this 7 days workshop on time series analysis. And I hope you all are enjoying all the sessions, all the previous sessions. I once again welcome our resource person, Dr. Brijesh Avasthi sir. I also welcome our Joint Secretary, Dr. Aarti ma'am. And if you have any query before starting today's session, you can ask to Dr. Brijesh sir, or we will start the session.
Otherwise, I am going to ask some question to the participants.
Yes, sir. Yes, बनता भी है सर अब तो 5 दिन हो गए.
Very good evening, everyone. Yesterday we talked about the time series analysis and we learned few methods in time series analysis. I hope every method is clear to you all. Now I'm going to discuss few more method in time series analysis. I'm just sharing my screen with you. Now, before I start today's session, I'm going to tell you some functions of Excel, which is going to help you in forecasting. You can see we have duration as well as we have sales. Right. I want to know the sales in the Q1, Q2, Q3 of 2022. How will I calculate it? I'm not going to apply the regression. I'm not going to use time series analysis. I'm just want to use the simple regression, a simple Excel function so that I can calculate it. Now, we have one function that is forecasting, right? Before I will calculate, I will use that function. What I'm going to do, I'm going to insert one line, right? That is what time one, and I'm going to make a series of it, right? Okay, I want to calculate the sales during this period, which is highlighted by yellow color, right? So I have a function that is what forecast equals to forecast. And I have this thing that is what forecast dot linear. With the help of this function linear, I can calculate the value, the expected sales during Q1 of 2022, Q2 of 2022, Q3 of 2022, as well as Q4 of 2022. How will I calculate? When I type forecast, I have got so many functions which is related to forecasting, and I'm going to take this linearity forecast.linear, and you can see this function required value of x. X is what your independent value, right? So I'm going to take the value 21 because of I'm going to do forecast for Q1 2022, and according to the serial number which I gave in the series, that is what 21. So I just click into that is what B22 cell where 21 is written, and I'm just going to put comma. When I will put comma, the second argument is what? Known Y series. It is mentioned that known YS, that is what? Known Y series. So this is what my Y series, and I told you earlier that your dependent variable is known as Y series, as well as your independent variable is known as X series. So I just select the Y series. Then I'm just going to put commas to get the next argument, and next argument is what? Known X series, right? And I'm just going to calculate the X series, right? And just enter it. I got the expected value because of my sales is not an integer. So I'm just going to eliminate the decimal part of it. So the expected sale in the month, in the quarter of quarter one of 2022 is 2231. Similarly, if I want to calculate it for the 2022, I will use the same function, and that function is what? Equals to forecast dot linear. I'm talking about 22. Then known Y series, this is what my Y series, comma, known X series, this is what my X series, and just entered, you will get it. Similarly, you can calculate it for 20, that is quarter 3 of 2022 as well as quarter 4 of 2024. Now I want to check that it is right or wrong, right? What I'll do, I'm just going to select it, select the data, then go to the insert, and insert, I will choose it linear and markers curve. Now you will see in this case these 2 points, the point number, these 2 points, this is what my quarter 1 and quarter 2 of 2022. I can change the series as well. What I'll do, right click, select data, edit, and I will select this duration, right, and click OK. And okay, now it's going to show me the quarters as well. All right. So in the quarter 2 and quarter 3 of 2022 is this, right? And it's already because of I draw a chart is already talk about the next sales as well. So this is a wonderful function. With the help of this, you can forecast. But there's a little bit difference in using this function. When you want to calculate the value only, you will use this function. When you are not going to calculate only value, you have to explain, you have to prove it also. That is why you choose this function. What's the basis of it? In that case, you have to apply a regression function, or you have to use time series analysis. That means you have to justify why this value, the forecasted value, is correct or not, or when, on which method you applied it. I hope it is clear to everyone.
Sir,
Right.
excuse me, sir.
Yeah, please.
Sir, actually, you told about forecast. There are some other formulas are there. So, can you explain me those formulas so that
You want to learn remaining function as well, right?
Yes, sir. Yes, sir. Yes, sir.
Okay. No issue. No issue. You just look at here.
Yes, sir.
If I'll type forecast, right? This is what forecast.ets. Through with this function, what we can do, we can establish the forecast value, right?
Yes, sir.
The target date. My targeted date is what, 21, which it was X value. Yes or no?
Yes, sir.
Then next is what values. The sales is my values, comma. The time series, that is what my timeline is, my time series. And according to me, there is no seasonality, nothing is there. Remember this thing, I'm going to tell you one thing. If you find any argument in a square bracket, yes or no?
Yes, sir.
After timeline, there are 3 arguments, which is in the enclosed in a square bracket. It is optional. It is not necessary that you are going to give the value in it, right? Like in this case, I'm just considering there is no seasonality. Done. When there is no seasonality, so accordingly it's going to calculate the value. That is what 2238. Yes or no? Now, if I'm talking about the another function, the second part is what is talking about the confidence interval. Do you understand the meaning of confidence interval? What is confidence interval? Anybody else? I discuss it with you. I think if I'm not wrong, I already discussed it with you. Confidence interval and as well as significance level. Okay. Can anybody tell me what exactly is confidence level, confidence interval, and significance level? Yes or no? Please let me know. Are you interested to know the answer of these questions? Oh, that means nobody is interested, right? Sachinji, nobody is interested. Actually, what happened? Your voice is not coming.
Yeah.
I think मेरा वाला जो problem है, that is throat infection, वो कहीं आप तक तो नहीं पहुंच गया. That is why you are so quiet today. Yes, I remember there are few candidates. They are very. Yes, Aditi. Today your voice is not coming. Right. So I'm going to tell you what exactly is confidence interval or confidence level as well as significance level. When we talk about any of the hypothesis, any perception, what happened? Suppose I'm saying today is today is a rainy day. Today is a rainy day. It is my perception. How I come to know that today is a rainy day on the basis of humidity, on the basis of temperature. That means on the basis of different parameters, I collect the information, and on the basis of that information, I can say today there will be a rain somewhere around 7 o'clock. Yes or no?
Yes, sir. Good evening, sir.
Very good evening. So when I'm saying that at 7 o'clock there will be rain today, on the basis of some factor, some evidence, I'm saying I'm giving this statement. Now what happened? I'm giving this statement, but I'm not 100% sure, and nobody is 100% sure. Am I right? Nobody is 100%
Yes, sir.
sure.
Yes, sir.
Right. So we will take a small part of, a small part of where you are not confident. Even you are correct, your perception is correct, but it is quite possible that it is not going to execute. Suppose I'm saying it is my perception that you all are attending these session, last 5 session very sincerely. It is my perception. Yes or no? It is my perception that you all are attended my lecture very sincerely. But Ravi sir and Aarti ma'am wants ki sir, you just check it. We want to check your confidence level. Right. And what happened? Ravi sir or Aarti ma'am conducted a test, and out of say 20 candidates, 18 students perform fantastic and 2 students are not performing well. That means my confidence goes down now.
Yes, sir.
It is quite possible that those remaining 2 candidates are also attended my lecture very sincerely, but due to certain reason, due to lack of confidence or due to some other technical error, they are not able to attend the test, or they are not able to perform well in that test. It is quite possible. Although my perception is correct, even then I have to consider this thing. Yes, it was my mistake, and I was thinking that 100% student get 100% of my lecture. Yes or no?
Yes, sir.
So the what happened when I'm going to develop a hypothesis? When I'm going to develop a hypothesis, there must be some confidence. That confidence level is known as confidence, right? The remaining part, suppose I'm 95% confident in a particular hypothesis. At 7 o'clock, there will be a rain. 95% I'm confident. What about 5% I'm not confident? That is what my significance level, right?
Yes, sir.
That is what my significance level. The chances of rejection, my null hypothesis, even it is true, even it is true. Right? Got my point? The chances of rejection my null hypothesis, even it is true, that is known as significance level.
Yes.
The chances of accepting the null hypothesis when it is true, definitely when it is true, that is called confidence level. So what we will do, we will on the basis of our data, we will find a value, we will find a upper limit and lower limit on the basis of that confidence, right? So
Yes,
the
sir.
difference between upper limit and lower limit, the difference between upper limit and lower limit is known as confidence interval. Got it, my point?
Yes, sir.
Right. You just look at here. I'm just going to draw some value. I hope it is visible to you all. And this is what a normal distribution curve, right? And in this case of a normal distribution curve, the center line is a mean line. Agreed?
Yes,
The
sir.
line is
Yes,
a
sir. Yes, sir.
mean line. Or I am 95% confidence now. My confidence level is 95%. What
Yes,
about
sir.
my significance level? That is 5%.
5
5%.
percentage.
So what I'll do, this is what my limit. This is what my limit. This is what lower limit. And this is what my upper limit. Right. And this part is 95%. This part is 95%. And remaining this part is what? 2.5%.
5%, 2.5%.
And this is also
2.5 percentage.
5%. Right. So on the basis of this 95% confidence level, we will get two values, upper limit as well as lower limit. And how we will get this value? Because of we never work upon population, yes or no? We always work on sample, right?
Yes, sir.
Right.
Yes, sir.
So we always work with sample.
Sample.
I'm just going to remove the population mean and I'm just going to put the sample mean.
Sample mean.
That is what? X
X bar.
bar. This is what my X bar. So how we'll calculate the upper limit or lower limit? The formula is what? Upper limit is equals to X bar plus 1.96. Yeah, I'm not going to write it here. That is what I'm just going to write. That is what X bar plus value of Z into standard error, right? And lower limit is equals to X bar minus Z into standard error. Now you will say, sir, this is very complex formula. Yes or no? Can I make it simple?
Yes, sir.
Okay. Just tell me one thing. What is this value of Z when I'm talking about 5% significance level? I'm talking about value of Z at 5% level of significance. That is what? 1.96. Yes or no?
Yes, sir.
Right. You can see in the student T distribution test table also. That is what at the when population is infinite and 5% level is significance level, and I'm talking about two-tailed test. Why two-tailed test? Because of rejection is left-hand side as well as right-hand side. So value of significance level is what? 1.96, right? So it become what? X bar, that is what? Sample mean minus 1.96 into standard deviation of sample. You can easily calculate now standard deviation of sample.
Yes.
Divided by square root of n. Now it is simple now. Now this is simple.
Yes, sir. It is understandable now.
Similarly, this plus 1.96 into standard deviation of sample divided by under root of n. With the help of this, we can easily find the upper limit and lower limit. And the difference, upper limit minus lower limit, the difference is known as confidence interval, right?
Yes,
This
sir.
is what confidence interval. If you have remember, yesterday I draw, suppose this is time series, and I found that I was forecasting the data. So this is what my forecast. This is what my forecast. And you have remember there is a such confidence interval is there. Yes or no? Have you remember? I told you this is what upper limit. This is
Lower
lower limit.
Yes,
And
sir.
this is what?
forecasting.
Forecast.
Forecast.
So this is the forecast value. Maximum is this and minimum is this. The distance between these two, upper limit and lower limit, is known as confidence interval, right? So I want to calculate the confidence interval. How will I calculate confidence interval? You just look at here. It is visible.
Yes, sir.
Yes, sir.
So this is what I'm talking about, confidence interval. What is the target date? I'm talking about 21 only. Yes or no? What I'll do, I'm just going to delete it. And it's better so that you will not get confused. I will this. Now, target date I'm talking about. This is what target date. And target date is 21. Target date is 21. Now, what I'm going to do equals to forecast dot ETS dot confidence interval. My target date is 21, comma, values. These are my values, comma. This is what my timeline, and just entered, right? So at 95% is my confidence level and 5% is significance level. I got my confidence interval is what? 192, right? And suppose if I'm using linearity, what I'm using? Linearity for forecasting. What is the forecast value? What is the forecast value? Equals to forecast dot linear, right? This is what value of X. This is what my Y series, and this is what my X series, and just entered. So what is the forecast for Q1 of 2022? Please tell me. Yes, please.
2000.
That is 2231.
Yes, sir.
Right. So that is what 2231. And what will be the maximum sale, expected maximum sale? That is 2231 plus this divided by 2. Why divided by 2? Because of it is a difference of upper limit and lower limit now. Yes or no?
Yes, sir.
So the maximum sale will be what? 2327. And what about the minimum? If I'm talking about minimum, so this minus bracket this divided by 2. Right, that is 2134. That means the expected sale for Q1 of 2022 is 2134 to 2327. Yes or no? That means the sales in Q1 of 2022, maximum is what? 2327, right? And minimum is what? 2134. Your sale will lie between 2134 to 2327. I hope it is clear.
Yes, sir.
Right. Okay. If I'm talking about the next equals to forecast, there is a seasonality. We already discussed this function yesterday. Yes or no?
Yes,
That is,
sir.
there is a seasonality or not. So this is
Yes,
what
sir.
my values, comma, and this is what my timeline, and just enter. I'll got the value 0. That means it shows that there is no seasonality. I hope it is clear.
Yes, sir.
Okay. Now, equals to forecast. And this what is going to talk about the statistics, different value of time series. That is what, if you are interested to calculate the alpha parameter, beta parameter, and gamma parameter, right? If I'm talking about the ARIMA model, have you heard this model, ARIMA?
No, sir.
Auto-regressive integrated moving average.
No, sir.
Actually, it is not possible in Excel, right? But you can calculate the alpha parameter, beta parameter, and gamma parameter, right? So suppose I'm interested to calculate the alpha parameter, right? So I will use 1. Got it?
Yes, sir.
And
Yes, sir.
just entered. You will get, what is the alpha parameter? That is 0.5. Yes or no? If I'm
Yes.
talking about, I want to calculate the beta parameter. So this is what beta parameter. Then enter. Beta parameter is what? 0.001. If I'm talking about gamma parameter, I will choose third one. That is what? Gamma parameter. And this is what? 0.000 something. Got it, my point? That means 0 only. So I can calculate the alpha parameter, beta parameter, and gamma parameter of my time series. Agreed?
So what exactly these parameters are? Alpha, beta, gamma?
I will try to explain you tomorrow. Actually, there is a auto-regressive model, right? What happened today? We are going to discuss AR. That is what? Auto-regression. Agreed?
Auto. Yes, sir.
And after auto-regression, we are going to talk. Yesterday, we talk about moving average.
Yes, sir.
Yesterday we talk about moving average. Now we are talking ARIMA is basically a combination of these two, right? This is what ARMA. Then the next comes what? ARIMA, auto regressive integrated moving average, right? So with the help of this, we are going to do forecast. Again, same thing. And it is a more complex method, although it is a very effective. ARIMA model is very effective. And in ARIMA model, we have different things. That is what lag. What lag you are using. I'm going to explain the concept of lag in the auto-regressive model. Then you will understand. So there are three different parameters. I'm just going to use A, B, and C. These are the values which I'm going to use in ARIMA, right? And this coding is talk about what kind of ARIMA you are applying. Got it, my point? It is a different coding of ARIMA, different categories of ARIMA, and with the help of this ABC code, you can analyze. Okay, this ARIMA is based on this, right? Got my? These are the category.
Okay, sir.
Actually, there are some applications, some add-ins which you can use in Excel, and you can get all the things very easily. That means you can apply ARIMA model in Excel as well. But you have to purchase those add-ins. And recently, before this meeting starting, I was discussing with Aarti ma'am, and we were talking about there are some like Excel stat, there are some NumLab, there are few add-ins, and that cost is around $100 per annum. Got your point? $100 per annum is the charges, license fee for those add-ins in your Excel. So it's too expensive, and that is why we are not going to purchase those. If I'm talking about corporate, or if I'm talking about companies, definitely they will purchase. And if we will purchase those add-ins, it's going to, you have to do very less efforts, and you will find a great results. If you have remember yesterday, we do a very hard work now. Yes or no? When we were using seasonality example.
Yes, sir.
Yes, sir.
कुछ ऐसा ही आज भी अपन लोग करेंगे. Done? Now look
Yes,
at
sir.
here. Now look at here. If I'm talking about this series is just like a linearity, na? There's a linearity in this series.
Yes, sir.
Right. And if I'm talking about this series, it is also a linear. Just let me know. Just tell me in this, there is a linearity or not.
Yes, sir. Exponential.
It's exponential. It's not linear, right? When it is not linear, if you are going to use the forecast value, what value you are going to use? Forecast, right? I'm going to insert time.
Yes, sir.
1 and just drag it. This is what, and I'm talking about time. I'm talking about time is 21, right? For next, because I want to do forecast, and this is what forecast. But what kind of linear? I'm talking about linear. So you just look at here, equals to forecast, but linear. And I want to calculate for next quarter, comma, this is what my Y series, comma, this is what my X series. Yes or no?
Yes,
What is
sir.
the forecasted value?
196973.
3.
And one important thing, your forecasted value for next quarter is lesser than previous two quarters now.
Yes, sir.
Yes.
Just a minute. Right. Now, we have another function that is growth. We have another function that is what?
Growth.
Growth. If I'm talking about growth, that is what? Y series. First argument is what? Y series. Right? Second argument is what? Your X series. And third argument is your what? Your next
New X series.
forecasting. Right. That just entered. What is the expected value?
289917.
Approximately 29,000 now? Sorry,
Yes, sir.
2,90,000. 2,90,000. So if I'm talking about this prediction is which one is correct? Linear or exponential?
Growth.
This is based on exponential. This is based on exponential, and this is based on linear. So which one is this one is correct? Yes or no?
Yes, sir.
Right. So these are the some function which is directly available in Excel, and you can use it for forecasting purpose. I hope it is clear to everyone.
Yes, sir.
Okay. Now I'm talking about some other method of forecasting, right? Are you ready?
So one question is,
Yeah.
so we have seen so many forecasting formulas like
Mhm.
forecasting ETS, forecasting is ETS, stat, linear, and all. Which one
Right.
is the most reliable one?
First of all, forecasting is not reliable.
Means most accurate. Accurate.
If I'm talking about the forecasting is depend on few factors only, right? And reality is totally different. If you will see the number of mobiles sold, I'm going to talk about the on the basis of time, right? I forgot the other factors like advertisement.
Yes.
Yes or no?
Yes, sir.
Yes, sir.
Government policies,
Competitors.
competitors, pricing. Yes or no? So there
Yes,
are
and
so many factors. Because of we are going to talk about only one factor, that is what time. And when I'm talking about time, definitely I will see the nature of data. If you have remembered yesterday, I show you different type of charts. Yes or no?
Yes, sir.
In time series, in different type of charts, you have to understand that there is a trend or not. And how you will find a trend? If you will find a line either incremental or you will find a line like this.
Zigzag.
This is called trend. Yes or no? It is
Yes.
not like this. Ki always you will find a increasing trend, sometimes decreasing also.
Yes, sir.
Right. So this is what number one. Number two, you have to understand that there is a seasonality or not. If there is a seasonality, so there if then in that case we have to do the treatment which we discussed yesterday. Have you remember?
Yes, a seasonality.
Right. So in that case, we are not supposed to use linear function or we are not supposed to use growth function. Both are irrelevant. Got in my point?
Yes, sir.
But in the case when I got this forecast, if I'm talking about, you can see what kind of trend you can see. There is a seasonality or not? Just tell me. In this
No,
case,
sir. No,
there is
sir.
no seasonality. Number one.
No.
Number two, when there is no seasonality and the correlation between these two, that means time and sales. What kind of correlation is there? Time and sales. If I'm talking about correlation, because of I'm getting very high
Positive
correlation, very high correlation. Yes or no?
Yes, sir. Direct
But,
correlation.
but I will check it. Right? I will check it. You just look at here. I will check it. 0.98. Yes or no? That means there is a linearity as well.
Yes, sir.
Yes.
If linearity, if I'm talking about the R square, this multiply by this, R square is also high. Definitely when there is a correlation is very high, so R square is also high. Right? The
Yes, sir.
number three is what? When we can see these two parameters, I'm not talking about other factors. I can directly say there is a straight line is more than sufficient to predict this value. Yes or no?
Yes, sir.
A straight line is sufficient.
Mm.
And with the help of a straight line, we can easily forecast the sales. So in that case, I will use this function. That is what I'm talking about 21. And I will use forecast dot
Linearity.
linear. Forecast dot linear. Right? And this is what X. And this is what
What?
Y. And this is what X series. And just enter. Right. And definitely you can see values increase, then decrease, then increase. Definitely in the next value chances it decrease now little bit.
Yes, sir.
Yes,
Right.
sir.
So it is what? We are very close to next forecasting now.
Yes, sir.
Okay, I'll do one thing. I'm just delete this thing. Control X. I will paste it here. This is what reality now. Yes or no?
Yes, sir.
And suppose we don't have idea about it. I'm going to do forecast this value equals to forecast. Forecast dot linear. This is what my X series, comma. This is my Y, comma. This is X series and just enter. What is the value? 2115.
Yes, sir.
2115. And what is the real value in the next term?
2250.
2250. Is there any very big difference?
No, sir.
There's no major difference, na? Ki suddenly there is a
Mhm.
difference of 500 or 700. Yes or no?
Yes.
And it is what forecast. It is not reality. It is not actual. And we can see our weather department is going to forecast now.
Yes, sir.
Can be 100% confident.
No, sir.
Similarly, we will get a tip from the share market. The chances of price increasing of the share is this. The chances of this.
Yes, sir. Yes, sir.
Can we rely 100% rely?
No, sir.
They will, in the last, what they will say? Subject matter to
Risk.
market risk. बहुत silently बोली है. They just pass this statement. Investment is a subject matter to market risk. Read all the documents very carefully.
Before
Right.
investing.
So similarly, we are going to do forecast, but they will also say it is just forecasting. You are not supposed to 100% rely on forecasting. Yes or no? So this is what
Yes.
forecasting. If I am talking about, suppose I will apply the same function, but growth. Suppose growth. What function I am applying now?
Growth.
Growth.
Now just see what happened. Equals to growth y, comma, x, comma, this, and entered. What is the value, expected value, when I'm going to use growth?
2647.
It is good or bad?
It is bad, sir.
That means this forecasting method is not correct now. Because of I can see my chart, I can see my graph, it's going to show me a linearity, not exponential growth.
Yes, sir.
Done. And now I am going to apply the same thing in this another data. That is why we can say what key you have to understand the power of what? Power of what? Common man? No, power of data visualization. Power of data visualization. You have to understand it. Now just look at here. I'm just going to draw a chart. Now you can easily understand there is an exponential growth
Yes, sir.
Right. Now I'm going to do forecasting. First of all, I'm going to do forecasting as linear, right?
Linearity, yes.
So equals to
Forecast linear.
forecast dot linear. This value, comma, this is what my y, comma, this is what my x, and this. And next time equals to
Growth.
growth. This is what my y, comma, this is what my x, comma, new x. Now just tell me which one is close to the actual or reality.
The growth one.
Growth one. Why growth one? Because of we can see in our chart that there is a
Growth.
exponential growth. Right. If I'm talking about, if I take only these 3 points, I'm talking about last 3 points.
Yes, sir.
Right. I'm just forgetting previous data. Can I take last 3 points? Suppose these 3.
Yes, sir.
And I'm going to do a forecasting on the basis of these 3. Right.
Yes, sir.
So equals to forecast dot linear. I will tell you why I choose linear, right? So which one is my x? That is 20,
Yes.
comma, this is what my y, comma, and what is my x?
17 to 19.
This, and enter. What is my forecasted value?
25, 4, 70.
Now just tell me which one is more closer.
This one. The last 3.
Last 3. Why this one is more closer? If you will see the market trend, that is why you doesn't rely on the entire data. You have to focus on what? The pattern. I can easily understand there is a linearity between last 3 years. Yes or no? Exact linearity.
Yes, sir. Exact linearity and high growth also.
Right. That is why I got the accurate value. If I will take this data, I'm talking about this data. That is from 1 to 11. From 1 to 11. And I'm talking about the forecasting for 20. Yes or no? I will get the wrong result. You can see. And there is a huge difference between the data equals to forecast dot linear. I'm talking about 20, comma, Y series is this, comma, X series is this, right? And you will be surprised. What is the expected? One 117,384 now. Am I
Yes.
audible or not?
Yes, sir.
Why it happens? Because of according to this data, I'm talking about this part only. This part, which is oval, right? According to this data, what happened? The regression line goes like this only. And there is a exponential growth in this part. We missed out it. So what happened when we talk about the forecasting, we take the entire data, we try to understand the pattern, and sometimes it happens we have to eliminate some data, and we will focus on the important data. Like from this I can talk about there is an exponential growth. If I consider the entire data, my exponential growth is what? 24 this month. Yes or no?
Yes, sir.
And when I just focus the data sales of last 3 years on the basis of this is what my expected, and this value is more closer to the reality, right?
Actual one. Yes, sir.
So we have to understand this concept as well. I hope it is clear to everyone. Very, 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 that means 100% clear.
Yes, sir.
Is there any doubt? Yes, everyone?
So does it mean that Excel is taking the immediate ones first in consideration while calculating forecast?
Can you repeat your question again?
So does it mean that Excel is taking the immediate growth rate for forecasting the next level?
Actually, Excel is going to calculate the growth rate in every brackets. You know, each and every interval.
It is making the averages of every growth,
Yeah,
right?
every growth. Then it is going to calculate. That is why it is what 2/4 this much of growth. Yes or no? If I'll calculate, if I'll take the data of this now, last
Yes,
4-year data, your result will be different.
Yes, sir. It was 25,477.37.
Have you checked? No, I'm talking about this is what linear now.
Yes, sir. It was.
It was linear. I'm talking about growth. You just look at here. I'm talking about these 4. Control C, Control V. This is what 20. Now growth equals to growth. Y series, comma, X series, comma, X, and entered. What we got?
25,4,160.
So it is perfect or not? Because there is nothing is growth now. Growth is not there.
Yes, sir.
It is like a straight line.
Yes, sir.
And growth part is there where we get the fluctuation or change in the values, or we can say
There,
slope,
there was a jump.
right? So that is why it's going to this value 2541. And
Yes,
in this case, when we talk about the straight line, but a straight line of last 3 years, if I'll take now 4 years,
yes, sir.
the
Yes,
value is
sir.
also changed. Yes or no?
Ye-
So it's
Yes, sir. got it.
totally, that is why tomorrow I will talk one research paper. I'll tell you in brief what exactly is there. We have a time series, yes or no?
Yes, sir.
And what we are going to do, we are going to apply different method of forecasting on that time series. Different method of forecasting of that time series. And what happened after applying different method of forecasting of time series, we will check which method is more accurate for that particular time series. Yes or no?
Yeah, okay, sir.
Suppose I'm talking about population. We have a data related to population of last seven decades, right?
Yes, sir.
And in last 7 decades, we have a data which is related to population. I just forget the last 2 decades. That is what 2021 and 2011, right?
Yes, sir.
I just apply a time series method up to 2020 and just forecasting for 2011 and
21.
2021. And now I'm going to check that my forecasting is correct or not, or which method is very close to the reality.
Actual one. Yes, sir.
Right. So if I'll get that this exponential growth is very close, that means in future we used to this we have to apply. We used to use this method only. We will not go with some other method. Yes or no?
Yes.
If I'm talking about petroleum pricing, if I'm talking about price of wheat, if I'm talking about price of cotton, there are so many items now. You can
Yes.
apply this forecasting method of any of the product and just calculate the forecast value on the basis of different methods, linearity, exponential, polynomial, and all, and see that which method is more accurate for your data. But you have to check it time to time. It is not like this once you decided for population exponential growth is there. Can you find the exponential growth of population in India after 2000? No.
No, sir. No.
You will not find the exponential growth. There is a linearity now. Got your point?
Yes,
So
sir.
you have to check it. Now, I'll come to the next point. What I'll do, I have to close it. Otherwise, no. This. Just a minute, huh? Right. Now, the next method, and next method is, little bit complex. I know it very well, but we have to understand it. And what should I do? I'll take this sheet, right? Tung, 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 tung. Can you see the pricing up to this 21? And we just try to understand the nature of data. What type of nature is there? It is like this. Done.
Non-linear.
Non-linear. No, there is a linearity, but there is a high fluctuation, right? Because
Yes.
of you will find it like this. The straight line is like this. We are moving surrounding with this. Okay. Now what I'll do, I'm just copied, Control X, come to the next sheet, Control V. Now there is one method, what exponential smoothing. Yes or no? Exponential smoothing. And with the help of exponential smoothing, we can find the forecasting. We can do forecasting.
Forecasting.
Right. And how exponential smoothing work, I'm going to tell you using function. You just look at here. In data, we have data analysis. Then we have moving average. Got it, my point?
Yes, sir. Moving average.
And just click OK. Now, not moving average, there is a exponential smoothing is here. Exponential smoothing, right? Just click on exponential smoothing, click OK. Now, this is what input range. So this is our input range now. This is our
Yes, sir.
input
Yes, sir.
range. And next is what dumping factor. What exactly is dumping factor? Just wait for 2 minutes. I'm going to explain you. Right now, my dumping factor is what? Say 0.5. 0.5 is my dumping factor. Right. And because of in my selection, I have selected the label and output. I want output here only. Right. And just click OK. Just click OK. Right. Control Z. Just a minute. Delete. Analyze exponential smoothing, and I want the ranges here only, and just click OK. So this is what the exponential smoothing. And with the help of this exponential smoothing, I can do forecasting for next years. Got it? What is the next year smoothing? Next year forecasting is what? 13.9135. Right. If I'll change the value, instead of 0.5, I will make 0.2. What happened? The value is like this. Right?
Yes, sir.
But what exactly is happening? There are two values. That is what one is alpha. One is alpha. That is what smoothing factor. Agreed? If you
Yes.
see, when I apply exponential, there is what? Dumping factor. Yes or no? If I am
Yes.
talking about the dumping factor, that is what D. D is basically what? 1 minus alpha. D is basically what? 1 minus alpha.
Alpha.
Is that clear?
Yes,
This
sir.
is what alpha. This is what 1 by alpha. And alpha is basically what? Smoothing coefficient.
Smoothing factor. Yes, sir.
Right. And what exactly is happening over here? I'm just going to show you like this. Suppose I will say this is what A. A equals to A. That means alpha is equals to. Alpha is equals to 0.5. Right. Then what is D?
1 minus 0.5.
1 minus this.
Yes, sir.
Equals to 1 minus this. And the formula is what? That forecast is equals to forecast for T. For T time forecasting is what? Basically that YT, YT minus 1, I will change it. I will take, this is what? YT is equals to YT minus 1 into alpha plus 1 minus alpha into forecast T minus 1. That means alpha is going to multiply by the previous actual sale, right?
Yes, sir.
And 1 minus alpha is going to multiply by with previous forecasting. Agreed?
Yes, sir.
So this is what forecast. This is forecast. And in this case, we don't have idea about previous price, yes or no, in this case?
Yes, sir.
Because of data is not available at this point of time. But in this case, we have idea about previous price, yes or no? But
Yes, sir.
we don't have idea about previous forecast. Can we consider that your previous price is forecasting for this year?
14.383.
Exactly same, we can consider it now. When we don't have data, in that case, what happened? We will consider previous sale as a forecasting only, right? So this is. So I just take it as a. Now, if I'm talking about this, now I'm going to do forecasting. How will I do? Going to do equals to. What is your previous sales? This 14.649
Yes, sir.
multiply by alpha. What is the value of alpha? This,
0.5.
0.5.
right? Now plus, what is your previous this forecasted sale? This
Yes, sir.
multiply by 1 minus alpha now.
D.
Yes,
Yes, sir.
Can I write 1 minus alpha? Alpha means
0.5. 0.5.
right? And just close and entered. What is the expected forecasting sale for next year?
14.516.
14.516. And what is the reality? Reality is this, right? What about next? This reality is this. What about next? Reality is this. Yes or no?
Yes.
And what exactly, actually, we don't have idea about the value of alpha. Okay, what value of alpha? That means what exactly is what value must be there for a smoothing forecast? Yes or no? I don't have idea anything.
Yes,
So
sir.
what should I do? What should I do when we don't have idea? My purpose is this. I want to calculate error. What I'm going to calculate? Error. And error is basically what? Your actual minus forecast now.
Yes, sir.
Your actual minus forecasting is what? Error. And because of some error are positive, some error are negative, what I'm going to do, can I take the absolute value A, B, S so that I can ignore the sign?
Yes, sir.
I just ignore the sign. I just going to take the absolute value. And there's one formula that is what? ABS. With the help of ABS, we can take
Absolute values.
absolute value, right? And now what I'm going to do, I'm going to calculate average of absolute value. Mean of absolute error. Mean of absolute error. And equals to average. Equals to average. Right. So average of this number, and just entered. What is the average error?
1.096.
And what exactly we want? That our error must be minimum. And when our error is minimum, that means our forecasting is very much accurate to the reality. Yes or no?
Yes, sir.
So I want to minimize this error. How will I minimize?
We have to change the alpha.
0.01, right? If I'll say 0.05, decrease now. 0.1. It increase now. Yes or no?
Yes, sir.
You just focus on this value. I'm talking about you just focus on this value because of I can't focus on both part. You just see.
Yes, sir.
At
When
present value is what? When I'm
1.
using 0.1. What is the average minimum error?
1.196.
196. Yes or no?
Yes, sir.
If I'll take 0.05, 0.05, then what happened?
It was
0.05.
1.096.
That is what? 1.185.
185.
Great. So this is far better now. If I'll take
10, sir.
0.02. 0.02. What is the value?
1.2.
1.209. Right. If I'll take value is 1, in that case 0.01, right? The value is what? 1.236. Okay. If I'll take 0.3, right? 0.4.
So take it as 8.
8. Oh, great. What about 9? And what about 1? Got my point?
Yes, sir.
That means for every other value of smoothing factor, you will get your error is going to affect. Yes or no?
Yes,
Now,
sir.
I'm interested to know that value so that our error must be minimum. My objective is this, my mean average error must be minimum. What should I do? Please tell me. Is there any process for it?
So there must be a process. Instead of using alpha, we must have use something else.
No, on a certain condition, we can get the minimum, we can achieve the objective because of my objective is to minimize this. Yes or no?
Yes, sir.
And if I'm going to change the value, right? If I'm going to change the value of A, it's going to affect. That means my A value of A must be less than equals to 1. This is the condition, na?
Yes, sir.
Why less than equals to 1? The value of A must be less than equals to 1. Why I'm saying like this?
Because sir, we want the minimum error.
Because of, if I will take say 2, if I will take A is equals to 2, what will be happen? What is the value of D? 1 minus 2, that is what, minus 1 now.
Yes, sir.
And this value should not be negative. Got him a point? The
Yes, sir.
value of
Error.
A, the value of A is lie between 0 to 1 only. It is the condition. The value of A must be less than equals to 0 to 1. Got it my point?
Yes, sir.
Right. The smoothing factor, the value of smoothing factor must be lie between 0 to 1. This is the condition. So this, we have certain condition. And number 2, objective is to minimize this. Now just look at here. Now I'm going to tell you another important feature of this Excel. I think you are aware or not. Have you heard about the solver?
No, sir.
Can you see there's one more add-ins, that is solver?
No, sir.
Just a minute. I'm sorry. Now, you have installed one add-in, that is what, data analysis in your system. Yes or no?
Yes, sir.
Right. Similarly, you can install a solver in your Excel. And the process is exactly same. That is what, file. Then options. Then add-ins, file, option, add-ins, and again go Excel add-ins. Click on go. And there's one like earlier you installed analysis tool pack, and this
Yes.
time you just take a solver add-ins. Yes or no?
Okay, sir.
And click OK. You will find solver here. Yes.
Yes, sir.
Now, what I'm going to do, I just click on solver, right?
Hmm.
And you can see in the solver pop-up box, first is what? Set objective. What exactly is your objective right now?
To minimize the error.
To minimize the
Error.
error. So I just click on this cell, where minimize the error is here, right? That is what 1.054. Yes or no?
Yes, sir.
I just click on it. Then what exactly we want? We want minimize it or maximize it?
Minimize it.
Minimize. I just click on minimize, right?
Yes, sir.
Then there's another box that is what by changing variable cell. By changing variable cells. So I want to change in my this cell only. That is what A alpha,
Yes, sir. Okay.
right? And what subject to the constraint, we have to give some constraint, right? So what exactly, I just click on add. What exactly is constraint? That this value must be less than equals to 1. Yes or no?
Yes, sir.
Less than equals to 1. And just click OK. We got the constraint now.
Yes, sir.
And just click on solve. Just click on solve. When I click on solve and I'm going to click OK, right?
Yes, sir.
What is the value of A?
0.74303.
0.743, right? That
Yes,
means
sir.
for this value of A, our error is minimum. Am I right or wrong?
Yes, sir. It is been minimized.
Right. So this is the value of a smoothing factor through which you can do forecast, and so that the difference between the forecast and error is what? Minimum. And definitely we know it very well that forecasting is not reality, but our effort is only for that, so that we can minimize the difference between the reality and forecast. Yes or no?
Yes, sir.
Right. So with the help of this A smoothing factor, you can see the difference which is coming. That is what 0.266, 1.165, 0.57, 1.94. Yes or no? Although they
Yes.
are very high difference like 2.3, 2.6. So it happens. And at this point of time, you can see the value is exactly same. Yes or no?
Yes, sir.
Your forecasting exactly meet with the reality. So with the help of this method, you can do forecast. Yes or no?
Yes, sir.
I hope so. It is clear to everyone. Now I am moving for next topic. Can I explain next topic?
Yes, sir.
This method is known as exponential smoothing. Please note down. This method is known as exponential smoothing. Right?
Yes, sir.
Now I'm going to take the same data. I'm taking same data, right? Control C. Control V. Oh. What happened? I'm going to use auto regression method. What method I'm going to use now? Auto regression. What exactly? We already discussed about auto correlation now.
Yes, sir.
What was auto correlation? Can anybody tell me? What exactly is auto correlation? Please let me know. Yes, come on, come on, come on. It is very simple. The correlation, the correlation among the series only, yes or no? And with
Yes.
the gap of time interval. That means if we have a series, if I'm going to find the correlation between the same series, but with the help of time series, suppose first 10, I have 10 years data, I just leave first year data. That means second to 10, and other side I'm going to take first to 9. Yes or no?
Yes, sir.
Yes,
And
sir.
now I'm going to find the relationship between these two series, that is called correlation. Because of I took a gap of 1 year now,
Yes, sir.
that is what leg one
Lag
leg,
one.
leg one. Yes
Yes.
or no? If I'll take a gap of 2 years, then
Year two.
Lag two.
leg two. If I'll take a gap of 5 years, then leg five. Yes or no? So
Yes.
similarly, in such a manner, you are going to find the what? Correlation now. On
Yes,
the
sir.
same method, we are going to find the regression. Done.
Auto read. Yes.
And that regression is called known as auto regression. That means a regression itself in the same series. Right. Now I will share. Now I just copied it. Control C. Control V. So this is what it's going to show me the leg one now.
Yes, sir.
Now Control V, and Control. Okay, I'll take 3 only. Right. This is called
Leg one.
leg 1,
Leg two.
leg 2, and leg 3. Yes or no?
Yes.
Now I'm going to do a fantastic thing. Control C, and I just paste it here. Control V. Right.
Yes, sir.
And because of in regression, we require the data in every series now.
Yes, sir.
That is why I'm going to, because of that is not usable, I'm going to delete it. And I'm going to select this data only. Yes or no? So this series is complete now.
Yes, sir.
That is what Control C, and I'm going to paste it here. Control V. Done.
Yes, sir.
Now this is what my Y. Y, that means
Right.
dependent variable.
Dependent variable.
This is what X1, this is what X2, and this is what?
X3.
Now you have to calculate the regression. Can you calculate? Now you become, now you all are expert in regression.
Yes, sir.
कि सर अब तो सपनों में भी regression आता है, right? So this is what data analysis, and
Regression.
regression. Okay. And in regression, first is what?
Right.
Y series. So this is what my Y series. Then X. This is what my X series, right? Because of we selected labels, that is why label. And confidence interval output. I want to get output on the same sheet. Where I will get the output? Can I get output at this point? And just click OK. You will get the output. Can we analyze the output?
Yes, sir.
Okay. So correlation is good,
Yes.
right?
Yes.
0.6 is good, but R square is not good, right?
Yes, sir.
So it is not good. And 0.06, this is also what? Not significant.
Yes, sir.
Problem, right? Oh my God, what is the p-value of this?
0.03.
No, I'm talking about second.
0.71.
Again, it is what? Not significant.
No.
0.2, it is also not significant. There's only
No.
one value, that is what? Leg 1 is significant. Yes or no?
Yes, sir.
Okay. So we have to remove the leg 2 and leg 3, right?
Mm.
So I'm going to calculate the regression again. This, and in this case, I have to select only leg 1 because of it is what? Significant, not significant. That is why I just removed leg 2 and leg 3 and just click OK and OK. Now you will see This is also not good. Actually, the value of R is down. R square is also less. And this is also what it is significant now. Okay. ANOVA is significant and P value is okay. So I'm just going to explain you that how you can deal it, right? Later on, we will use another example for it. Right, everyone?
Yes, sir.
Okay. So what exactly we found that the intercept is what? 5.35 and leg 1 is what?
0.06.
0.06. And what I'm going to do? Forecasting now.
Yes, sir.
So I'll just type here. Forecast. So if I'm want to do forecast for this, because of if I'm talking about this, forecast is not possible. Why forecast is not possible? Because of previous leg is not available. Yes or no?
Yes, sir.
Right. So I will start from here. Equals to, this is what? Intercept. Yes or no?
Yes.
We will we are going to develop a regression equation, that is what? Y t is equals to 5.35176 plus
Plus 0.60
0.60342 multiply by y t minus 1
1.
previous. And you can see this is your leg 1 now for this time period. This is your leg 1
Yes.
Yes, sir.
and this value is same now.
Yes, sir.
If I'm talking about this time period, this is your leg 1
Yes, sir.
and it is available here only,
Yes, sir.
right? So that is why I'm talking about previous one, because of in this case leg 1 is not available. We are not going to calculate the forecasting for this. We are going to calculate forecast for next. So equals to, this is your value of constant, right? I'm going to make it free absolute plus, this is your coefficient. Again, I'm going to make it absolute, multiply by what? Leg, yes or no? Leg 1?
Yes, sir.
Just entered. What is your forecasted sale? Forecasted price 14.03.
Yes, sir.
And just drag it. Right? So this is what a AR model. This is what? AR, auto regression. You got it or not?
Yes, sir.
Because of it is depend only one leg, that is why there might be a error. Can we calculate error? If I want to calculate error, how will I calculate it?
So expected minus observed. Observed minus expected.
Equals to actual minus forecast. And I'm
Yes,
going
sir.
to make it absolute, right?
Yeah.
Absolute. Right? And then can I calculate the average?
Average.
Because of it's going to tell me about the
Error.
average error. What is the average error?
0.9.
0.913 is the what? Average error. Right? Now, I will use another data for this. Which file I will use? Can I use this number?
Yes, sir.
Right. And what we will do, copy and paste. Now I'm going to create a leg. Control C. This is what leg 1, leg 2, and leg 3, and leg 4, right? We will take a 4 leg. Because of we are going to do, solve this problem on Excel, na? You can take many legs. If you are going to do it verbally, na, manually, in that case, you will not take this much of leg. Right? Now, what next? What next?
Regression.
Correct. Regression. This,
Y will
and then this,
X value.
this, output. Can I calculate output here only? And okay, we got the output. You just see, what about the correlation is perfect?
Yes, sir. R square is good.
R square is also good. This is also significant.
Yes, sir.
P value is, oh, problem. I'm sorry. This method on the basis of what?
Lag.
On the basis of what? Auto regression model, we cannot do forecast,
Forecast.
right? Because of each and every p value is what? Not significant.
Not
We want
significant.
all values significant. At least 2 or 3 values must be significant. Agreed? Okay, no issue. We have another data, na? This one?
So it was the problem of the auto regression or the data?
Hey, this is a problem of our data, na? My data is not going to support auto regression.
Yes, sir.
Right. Okay. So I'll take one data. I will try on this, right? Or we can try on this. एक बार इस पे try करके देखते हैं. Let's see what happen.
Yes, sir.
You are getting bored?
No, sir.
Please let me know if you are getting bored. I have some jokes. Leg 1, 2, and 3. Right. Okay. Oh, regression. Yes.
Dependent
That's
variable.
Another
Independent
variable.
variable.
right. This,
Okay.
this, and okay. Finally, we got it, right?
Yes, sir.
Wonderful. Wonderful, wonderful. Can we do forecast?
Yes, sir.
Forecast, right. Equals to, what is your intercept this?
Yes,
1.85517.
1.855.
Plus, oh, why I'm going to calculate forecast here? There are 3 leg now. Leg
Yes.
1, 2, 3. I have to start forecasting from this point. Yes or no?
Yes, sir.
If for previous forecasting is not possible because of leg is not available now.
Yes, sir.
Okay, so equals to what is intercept is this?
1.85517.
Right, plus leg 1 is this?
0.77.
Multiply by leg 1 is this now?
Yes.
Plus,
Leg 1 is
yeah,
number 2, sir.
Just previous.
Okay.
If I'm talking about this, what coefficient of leg 2
Yes, sir.
multiply by leg 2. This is what leg 2
Okay.
4.0.
plus coefficient of leg 3 multiply by leg 3. Right?
Leg 3.
Just entered and just drag it.
Four.
Got it?
Yes.
Can we calculate the error? Okay, we will do one thing. We
Sir,
will
there is
check
a very
it.
less error.
We will check it graphically, right? That our forecasting is correct or not. What do you think about this forecasting?
It's very much accurate, sir.
If I'm talking about yesterday, we did forecasting of the same data, na? With the help of different methods, seasonality.
Yes, sir.
Have you remember or not?
Yes, sir.
Right. And that method was very accurate. And this is also very accurate, na? Yesterday we used moving average, and this time we use with this regression.
Yeah.
That is what auto regression.
Loading.
Yes.
Okay, na? With the help of this auto regression, our forecasting is also a good. It is also follow the trend line. Yes or no?
Yes, sir.
Ups and downs, you can see. Now like this. So this is also a wonderful method. The moment I will get the, suppose the next year sale is 7.9. Suppose next quarter sale is 7.9. I can predict the next quarter now. Right. Again, suppose I got that is what 7.5. Now I can predict the next quarter. Because of the sale is depend on the previous 3 lakhs.
Lag value.
Previous 3 lakhs. And if I'll say that it is also correct or not, I'm going to draw a chart. Now you can see. Right? Here we got, I got a problem.
A gap is there, sir.
Because of there's a seasonality, na. I don't have idea about the seasonal, na. So I'll
Yes.
take 6.8. Right. So it's totally because of we have to our data is totally based on seasonality. If seasonality is going on, this chart is perfect. The lag method, that is what auto regression method is perfect. And yesterday we talked about the moving average. And if I'm talking about ARIMA model, which we are not able to cover with the help of this, I try to arrange. I can't promise to you. I will try to arrange some trial version of that add-ins and share it with you by tomorrow afternoon. Right, everyone?
Yes, sir.
There will be one exe file and you just install that exe file so that we can discuss about the ARIMA model as well. So is there any doubt up to this point? Please let me know.
Sir, can we calculate the error as well of this question?
Yeah, definitely we can calculate. Definitely we can calculate. Can I delete the chart?
Yes, sir.
Right. And can I remove this data also as well?
Yes, sir.
Right. I'm not, because of I'm not talking about the forecasting. Okay, delete. Now, equals to ABS. That is what absolute difference between the actual minus forecasted. And just click. And that is what mean of absolute error
Yes, sir.
is equals to average of this, and done. What is the average?
0.31.
Right?
It is a nice forecast, sir. It means.
Yeah, it's a wonderful. Actually, we can't say that if the value of average forecasting now, it must be close to zero. If you have remember when I was talking you about regression, there is one assumption that residual must be equals to zero. Have you remember?
Yes, sir.
And this is also part of that, na? Ki residual. This error is known as what? Residual.
Yes.
And the residual, the value of residual must be equals to or very close to zero. It is rare chance that you will get the exact value zero.
Zero. Yes.
But that is not possible practically.
Yes,
Right?
sir. Got it, sir.
Okay. There's one method which you can apply, that is insert. That is what you can do. You can do a square of the error. Yes or no?
Yes, sir. We can.
A square of the error. And what I'm going to do equals to average of this. That is also what? 0.13. Right?
Yes, sir.
This is also a what? Equals to 0. Any doubt up to this point, please let me know. I think today's session was more complicated as compared to previous one.
No, sir. Today's was easier than earlier one.
Okay. There were many steps, right?
Yes, sir, the average, then CME, then what?
Right. But definitely you enjoyed a lot, especially these two sessions.
Yes, sir.
Right. Any doubt, any question, please let me know. No doubt.
So I have my yesterday's doubt still.
What was your doubt, please? Can you recall? Remind me
It
again.
was the uh, exchange rate of the US dollar and Indian rupee, how we can predict the
Okay.
price.
Right.
Because there are two CDs with
No,
reference time as well.
you just do one thing. You just share your data with me, right? Then we will discuss that what method is more accurate for your forecasting or this method, time series analysis method is appropriate for your data. Got my
So can
point?
you
You
take
just
all
share a sample data for send to me.
okay, fine, sir. I'll send.
Right? How you will send to me?
I'll send you on your mail ID, sir.
So how you will find my email ID?
Please, sir, please give me your mail ID.
You just type my name as it
Yes.
is,
Yes, sir.
brajeshawasthi@gmail.com.
Okay.
Right.
Yes, sir.
Yeah. Any other doubt, please?
Sir, yes, sir. I have one doubt, sir.
Yeah, please.
Sir, in ARIMA, an auto-regressive model,
Mhm.
what is PDQ, sir? What are those PDQ within brackets, sir?
Actually, it's talk about the what exactly lag you are taking, like 1 lag, 2 lag, 3 lag, or normally in ARIMA we will use only 1 lag. Yes or no? In normal case. And most of the time we will take one. So this is what ARIMA bracket 1 comma. Got my point? The other
Yes,
two
sir.
factors are which is related to what kind of relations is there or what kind of predictions you want to do. It's a technical term, and most probably I'm going to discuss it tomorrow in detail. Right. Actually, my add-ins is not working. It's expired, which I told you that there is what Excel Stata. It cost $100 per annum. That is expired. It's not working. And I was planning that I will like demonstrate that add-ins to you all, but I will try to find out some trial version and share it with you tomorrow, so that you just at least learn it. If you don't want to purchase it, it's your wish, right? Because of I am also not going to purchase it. But what happened? I want that you just try to understand how we can use it. So the moment you will find the same add-ins in your college or some other organization, you can use it, right? Any other doubt, please?
May I, sir?
Yeah, please.
Sir, not exactly doubt, just I would like to confirm.
Mhm.
So when we have different types of data to analyze,
Right.
just we can go with the Excel model kind of preparation, where we are preparing our all the kind of models like auto regression model or all. Whenever
you
we
can you can
go-
you, you can use Excel for any kind of data. Excel doesn't have any restrictions.
Sir, just let me, sir, I just want to conclude or want to conclude my part.
Right.
Just in one sheet, I prepare one data sheet, and then in another 3-4 sheet, I just make some models, auto regression model or other models.
Right.
Once I feed the data at once, and where the residual is 0, that model feeds, and then I'll find that where is the residual is 0. So once I get that in third number model, I get perfect residual 0 or near about. So that
Right.
model fits to that, and then I will use that model for that particular data, and it will be helpful.
Perfect, perfect, perfect.
Okay, sir. Thank you. Just I would like to conclude that part. As I
Right.
got this point, just conclude. Thank you.
No, that's perfect. Yes, anyone else? Okay. So over to Aarti, ma'am.
So on behalf of Inspira Research Association and Chandragupta Institute of Management, Patna, I wish to thank you from the deepest of my core of my heart for this 6th day of time series analysis faculty development program come workshop. And sir, it was actually very worthy, and I'm sure the participants, the candidates, it must have exceeded their expectations. Not only it has met their expectations, but definitely it must have exceeded their expectations. So thank you so much once again, sir, for being here with us and enlightening the students with your great and in-depth knowledge on Excel and other research tools. So tomorrow will be the last day. So I request all the participants to kindly, after the session, keep 10 minutes for giving the feedback to the to sir, because in spite of being poor health, he ensured that he takes 2 hours every day and clear all your doubts and concepts. Thank you so much on behalf of both the institutions, Inspira as well as Chandragupta Institute of Management, sir. Thank you.
Thank you very much, ma'am. Thanks a lot.
Thank you, ma'am. Thank you so much, Vijay sir, once again.
Thank you very much, sir.
And tomorrow is the last day of this workshop on effective report writing, how to write the research paper. And we will also announce our next event tomorrow, the valedictory. And as Aarti ma'am said, we will give you 10 minutes for the feedback about Dr. Vijay sir classes. So thank you so much once again, Dr. Vijay sir, and please take care of your health.
Thank you very much, sir. You too also, sir. Yeah.